In this video, we're going to be solving 3 more equations involving multiple angles when we talk about trig equations. So let's go ahead and start with this first one up here. It says solve the equation tangent squared of 3 times our angle is equal to 1 for all possible degree solutions. So we want our results in degrees, and we want all possible, okay? Also, we want to check this graphically, which I'll do before we tune out of this video. But let's go ahead and start with this. If we said we have tangent squared of 3 times an angle equals 1. Our first rule of thumb is that we're supposed to be getting this trig function by itself before using the inverse tangent. So the only thing keeping us from doing inverse tan right now is the fact that it is squared. So we're going to take the square root of both sides of this equation. And what we end up with here is this. Well, then the tangent, oops, I also wrote that squared again. It's tangent now, just tangent of 3x is equal to plus or minus 1. It's very important that when you take the square root of something that you put plus or minus out front. So now what we're going to do is we're going to do the inverse tangent of both sides. And what we really get is this. Well, then 3x equals the tangent inverse of plus or minus 1. So let's go ahead and start with this. If I were to put both of these in my calculator, I want everybody to see this here. If I were to put 1 in and I do the tangent inverse, I get 45 degrees. And if I were to put a negative 1 in, and we do the tangent inverse, we get negative 45. Either way, what we're saying is this thing right here produces a reference angle that is 45 degrees in measurement. So we'd say, well, all possible angles that could produce this have to have 45-degree angle measurements. And that being said, we say also we have to take into determination or take into account also the signs to determine what quadrant we were in. So since tangent came out to be both positive and negative 1, it's actually all 4 angles here. We have 4 angles that make this work, okay? And since all of these reference angles are 45 degrees in size, these things are 45 degrees, then we can say, well, then we've got 4 angles here. We want to list them all. So we say, all right, well, I've got 3x is equal to 45 degrees plus 360 degrees. Actually, we're doing tangent here, so we'd say plus 180 degrees k, since that's its period. 3x equals 45 degrees plus 180 degrees k. We also get 3x is equal to 135 degrees plus 180 degrees k. That's this one right here. We say going over here, we say 45 past 180. This is 3x is equal to 225 degrees plus 180 degrees k. And we say also 3x is therefore equal to 45 degrees shy of 360, which is 315 degrees plus 180 degrees. Okay. So what we're going to do now is we say we listed all possible degree solutions of this on all of these. We need to split all of these by 3 because we still haven't gotten x isolated in each of them. So when we divide each of these by 3, I'm just trying to come up with some room here. We would say then I get 4 answers. X equals a third of 45 degrees plus 180 degrees k would be a third of 100, or 45, which is 15. 45 divided by 3 is 15. We say 15. And if we divided 180 by 3, we get 60 degrees k. So we would say 15 degrees plus 60 degrees k. We also say that we got, looks like we say 135 divided by 3, which is 45, plus 60 degrees k. We say also we got 225 divided by 3, which is 75 degrees, plus 180 degrees divided by 3 is 60 degrees k. And then last but not least, we say 315 divided by 3 is 105 degrees, plus 180 degrees k divided by 3 is 60 degrees k. So these are all 4 of our solutions right here. Listed out so that they present all possible solutions to this. Okay, so let's take a look at another example here. Sorry, I'm going to skip the graphically deal, but we say, all right, example number 6, 4 sine squared 2 theta minus 1 equals 0. Again, we want to find all possible solutions for this, and we want them in radians. So let's take a look at what we have. We say 4 sine squared of 2 times our angle minus 1 equals 0. The first thing we want to do is add the 1 and divide by 4. So what we get is this. When we add 1 and divide by 4, really we get sine squared of 2 times our angle is equal to positive 1/4. So now again, we have to do the square root of this, which by the way, when you do the square root of a fraction, is the square root of the top and the bottom. So we get sine of 2 times our angle, sine of 2 theta, is equal to plus or minus 1/2. Since we took the square root, we had to write the plus or minus. So now we'll do the inverse trig function of both sides, the inverse sine. So we get 2 theta is equal to the sine inverse of plus or minus 1/2. And so we get to go carry this out on the calculator as well. Again, we'd say if we were to type in 0.5 and do the sine inverse of this, we get 30 degrees. And if we do 0.5 negative and do the sine inverse of this, we get 30 degrees negative. So really, what we find out here is this. we have to sketch this out. We say we had a 30-degree reference angle. Oh, and by the way, since sine, we were finding the sine of something, and the sine came out to be both positive and negative a half, we actually have to take into account all 4 of these quadrants here. So since each of these angles here is 30 degrees, we'd say, well, in this first one here is 30 degrees. We'd have 150 degrees here. We'd have 210 degrees here. And we have all the way over here, this would be 330 degrees. So we'd get 210 in degrees, 150 in degrees, and 30 in degrees. We wanted to do this in radians, however. So what we end up with is instead this. We say 30 degrees, that is a sixth of pi. That is a sixth of 180 degrees. So 150 is 5 of those 30-degree angles. So we say 5 pi sixths. Down here at 210, it would be 7 30-degree angles. So 7 pi sixths. And then over here we say this is 11 30-degree angles. So this is 11 of these pi sixths things. So all of our angles can be represented this way. We say, well, then 2 theta equals this, pi sixth plus 2 pi k. 2 theta also equaled 5 pi sixth plus 2 pi k. 2 theta also equals this 7 pi sixth plus 2 pi k. And 2 theta also, last but not least, equaled 11 pi sixth plus 2 pi k. So if we split all of these in half now, what we end up with is this. Then theta must be half of pi sixth is pi twelfths, plus half of 2 pi is 1 pi, so we say plus pi k. And again, we'd say here half of 5 pi 6 is 5 pi twelfths, and half of 2 pi k is pi k. We can see how we're just going to get pi k left over on all of these, but we'd say half of 7 pi 6 is 7 pi twelfths plus pi k. And we say this last one here, half of 11 pi 6 is 11 pi twelfths plus pi k. So these are all possible solutions to this equation. Okay, so this last one we're going to look at here involves a reciprocal trig function, but it says find all possible and radian solutions. Okay, so we get root 3 cosecant of 3 times our angle equals 2. Again, let's start by isolating the trig function like we're used to doing. So we're going to divide everything by root 3. And I'm going to make a note here. Because we're dealing with a reciprocal trig function, let's not go ahead and rationalize this right here. Let's leave it as 2 over root 3, because I'm going to use our reciprocal identity that says, well, if the cosecant of 3 times an angle is equal to 2 over root 3, then its reciprocal, which is the sine of 3 times the angle, would be the reciprocal of this. And so now that we've got this trig function by itself, we can do the reciprocal trig function, or sorry, inverse trig function of both sides, which cancels this out, and we just get left with 3 theta. And 3 theta is equal to the sine inverse of root 3 halves. So again, we're going to grab our calculator here, and we say, all right, well, 3, I want the square root of this, I want to divide it in half, and it's that. And we're going to do the sine inverse of this, which gives us a reference angle of about 60. Well, it is 60. So we say, okay, well, 60-degree reference angles. It's got to look something like this. And all of these being 60 degrees, we say all students take calculus. We know that this came out to be a positive root 3 over 2. So if sine's positive, we must have been up here or over here. So our two angles, and we want to do this in radians. We say 3 theta and 3 theta. In radians, we say 60 degrees is a third of pi, so we say pi thirds. And also, it would take 2 pi thirds to get over here. So 2 pi thirds would be 120 degrees. So we get pi thirds plus 1 period length times k. And we say 3 theta is equal to 2 pi thirds plus 2 pi k. Where 2 pi is just all the coterminal angles. Any multiple of 2 pi on top of pi thirds, it's just going to be coterminal with it anyways. So now we're going to divide everything by 3 to isolate the theta. So in this first instance, we get a third of pi thirds is pi ninths. And we say a third of 2 pi is just 2 pi thirds. And we'll just write the k off on the side. And then again over here, we say if I divided this by 3 and divided everything over here by 3, we would get theta is equal to 2 pi ninths plus 2 pi thirds k. That's a k. Okay? Cheers.